over what you need to do for the week of January 18th to the 22nd, and we are going to be doing page 140 on your DR, page 140, 141, and you'll note that you can cross out the reviews because you don't need to do those, and page 142, and continue on to page 143, and then stop at the bottom of page 143. Again, cross out that review because you don't need to do that. This section is part of section 2, I believe. And then we'll also move into section 3. So let's move back up to where we should start. And the first question comes from a question about the geologic column. So let's go back to the book. And that actually is a question right here on page 1 or page 60. What they want to do in that question is they want you to sequence the events of what a geologist would do to collect data on rock sequences to build the kind of the dictionary of the geologic column, which is used by scientists all over the world to know how old layers are and how the layers of the earth above in the crust are arranged, so we can tell the story, the history of the earth. If you go back to the Rock and Fossil DR, once we go past this question here, which we just did, we're going to talk about cross-cutting features. So the interesting thing about cross-cutting features is that, let me see if I can make a new note. So there are two types of cross-cutting features. And the two types are faults and intrusions. Now the first one, faults and intrusions, you have to understand that before you have rock layers, you cannot have a fault or an intrusion because the rock layer is not there. So let's start with faults. I'm just going to move this down a little bit. Maybe make it smaller. There we go. And move back up. So when we have rock layers, geologists assume at first that the rock layers are undisturbed, meaning that nothing has affected them. And when we look at rock layers, we know that the youngest layers are at the top, and we know that the oldest layers are at the bottom. And remember, this is called the principle of superposition. But every time we have plates moving, we have things that happen to these rock layers that make it so they're not attributed to the principle of superposition. One of the things that happens is that sometimes rocks break. Maybe the plates are pulling together or pulling on the rock layers, and they finally break, and sometimes they create what's called a fault. And we've already talked about faults. So one kind of fault, if you recall, is a normal fault, and the other type of fault is a reverse fault. So this particular case, we have this fault, these layers that are have been broken, and right here is the fault. Well, the question that you're being asked here is why is a cross-cutting feature always younger than the rock layers it cuts across? Well, if you have a fault, wouldn't you have to have the rock layer there first for the fault to occur? And let me go down to intrusions, because intrusions are also a cross-cutting feature. Cross-cutting means that like something cuts into the rock layers. So if you have an intrusion, you have your rock layers. And what happens is deep down in the earth, you get magma flowing up into these rock layers. So it would kind of be like maybe the magma would flow up through a channel and it would go through the rock layers. And that's called an intrusion. So we have faults and intrusions. And this is magma going up in. Anytime you have either an intrusion or a fault, you'll have, oops, I don't know what just happened there. You'll have to remember that the intrusion and the fault had to have happened after the rock layers were there. It's kind of like you can't eat a sandwich unless the sandwich is there, right? Well, you can't have an intrusion into rock layers unless the rock layers are there first. So let's read that section in the book and see what they have to say, and then we'll answer some of the questions. So it says, geologists often find features that cut through existing rock layers. Geologists use the relationships between rock layers and the features that cut across them to assign relative ages to the features and layers. They know that those features are younger than the rock layers because the rock layers had to be present before the features could cut across them. Faults and intrusions are examples of features that cut across rock layers. A fault is a break in the Earth's crust along which blocks of crust slide relative to one another. Another cross-cutting feature is an intrusion. An intrusion is molten rock from the Earth's interior that squeezes into existing rock and cools. Figure 4 illustrates both of these features. And let's go back. So you can answer, go down. You can answer this question right now. Why is a cross-cutting feature always younger than the rock layers it cuts across? Then, once you answer that question by looking at the paragraph I just read and thinking about the notes I gave you, you can move on. So in this section, we're going to choose the term in column B that best matches the description in column A and write your answer in the space provided. So this is just vocab. Okay? So there are two other types of ways that rock layers are disturbed. I told you about two of them, and those two are faults, intrusions, but sometimes the rock layers get folded, and we already talked about this. Like you have the rock layer to start with, youngest over oldest, but then you either have some type of plate movement where it's converging and the rock layers get squeezed together and forms like anticlines or synclines. Sorry, hold on a second. Monoclines, all types of folds. And these folds are another way that rock layers are disturbed. So remember your anticlines and synclines. So folding is another way that rock layers can be disturbed. And then finally, folding, faulting, intrusion, and then sometimes the rock layers get pushed up on one side. It's really kind of a cool feature. If those rock layers get pushed up, that's called tilting because they're tilted. Okay, so folding, faulting, tilting, and intrusion. Tilting, sorry, let me change this to tilting. Tilting, folding, intrusions, and faults are 4 ways that rock layers can be disturbed. So let's go back to the question. And you'll see there's fold, fault, tilt, intrusion, and superposition. Well, if you go back to this page here, you should be able to answer those questions right here. Okay? Let me read the second paragraph. Geologists assume that the way sediment is deposited to form rock layers in horizontal layers has not changed over time. According to this principle, if rock layers are not horizontal, something must have disturbed them after they formed. This principle always allows geologists to determine the relative ages of rock layers and the events that disturb them. Folding and tilting are two additional types of events that disturb rock layers. Folding occurs when rock layers bend and buckle from the Earth's internal forces. Tilting occurs when internal forces in the Earth slant rock layers without folding them. Figure 5 illustrates the results of folding and tilting. Remember, any of these events are always younger than the rock layers they affect, because the rock layers had to be there first. Okay, so let's move on. Now we're going to talk about gaps in the record. So sometimes we get rock layers where, let me scroll down a bit here. So we have our rock layers and maybe wind or water erodes away part of that rock layer. So you might have a rock layer, lots of rock layers. And let's say we get wind from one direction for maybe thousands and thousands of years, maybe a long time. And that wind blows across and it gradually wears away maybe some of this layer. Some of that layer gets worn away, that there's only maybe a little bit left of it and gets eroded away. Okay? So that's what this next section is going to be about. Like, when we look at a rock layer, why is this missing? And maybe over time another rock layer was added, so we're trying to figure out, is there a missing layer here? If so, why did that layer go missing? Was it wind erosion? Or water erosion? Or something called non-deposition, like it never even got laid down? So we're trying to figure out what happened. So really, scientists are looking at these rock layers and the fossils in them to solve the mystery of the Earth's story. So let's go back and read some more. Turning to page 62. It's called gaps in the record, unconformities. So these things that are caused by missing rock layers are called unconformities. So it says faults, intrusion, and the effects of folding and tilting can make dating rock layers a challenge, like figuring out the age of the rock layers. But sometimes layers of rock are missing altogether. So we're missing an entire layer of rock. And that creates a gap in the geologic record. To think of this another way, let's say that you stack your newspapers every day after reading them. Now let's suppose you want to look at a paper you read 10 days ago. You know that the paper you want should be 10 papers deep. But when you look, the paper is not there. What happened? Perhaps you forgot to put the paper in the stack. Now instead of a missing newspaper, imagine a missing rock layer. So we're missing evidence. Missing rock layers create gaps in rock layer sequence called unconformities. An unconformity is a surface that represents a missing part of the geologic column. Unconformities also represent missing time. So if we're missing a rock layer, we're missing a story. We're missing like a page in a book, like we don't know what happened. And that's not recorded in the layers of the rock. And when geologists find unconformities, they must question whether the missing layers were actually present or whether they were somehow removed. Figure 6 shows how non-deposition and erosion create unconformities. So let's look down. So there's two ways that that missing rock layers can be created. The first one is called, non-deposition. And in non-deposition, what happens is there's something in the way of that rock layer being laid down. So deposition in this low area occurs as sediment is regularly supplied. The sediment supply is cut off and deposition stops. And then finally, number 3, sediment is supplied again and deposition resumes. So something is blocking a layer from being formed. That's called non-deposition right here. Okay? Then another type of way that rock layers are not laid down or are missing is if erosion causes a layer to be kind of taken away. So in erosion, what happens is that the layer is exposed to wind or water by erosion, and eventually it wears down that layer is no longer there. So you can see here these little circles representing wind flowing across this layer that eventually exposes it and causes the unconformity. Okay. Now let's go down the next page. There are some different types of unconformities, and this can get really confusing, so if you have questions, you can message me. So remember, an unconformity is simply a missing rock layer. Most unconformities form by both erosion and non-deposition, but other factors can complicate matters. To simplify the study of unconformities, geologists put them in three major categories. So our three major categories are disconformities, nonconformities, and angular unconformities. And the three diagrams at the right are going to try to explain that. So figure 7, a disconformity exists when where part of a sequence of parallel rock layers is missing. While often hard to see, a disconformity is the most common type of unconformity. Then the next one is called a nonconformity. A nonconformity exists, so we're looking at this one right now. A nonconformity exists where sedimentary rock layers lie on top of an eroded surface of non-layered igneous or metamorphic rock. So what happens is you've got this rock layer here, that's not layered. So we've got, you see there's no layers there. And then on top of it, you've got the layers. Well, that area right there, so right along here, is called a nonconformity. Doesn't conform, right? It's not conforming with the previous layers. And then if we scroll down, an angular unconformity is kind of cool. I think it's neat. Basically what happens there is that you've got layers that are tilted, and then you've got an eroded area. So right there, I guess I should make those, but you can see right along there. And then the layers above it are at a different angle, and that's called an angular unconformity. Okay, so going back to our question, it says when a layer or several layers of rock are missing from a rock layer, the gaps are called unconformities. So that's a true or false question. So look back on those pages to figure that out. Then scrolling down, name 2 possible explanations for missing rock layer in a rock layer sequence. Well, go ahead and look right here, because the answer is right there, okay? Page 62. And then if you go back, let's see, number 15, an unconformity is called, and you can look on this page right here, types of unconformities, to get that answer. Number 16, that I think is going to be on one of these 2 pages, so you'll have to look through, see if you can figure that out. And then types of unconformities, well, if you look here, it gives you the page number. So look on page 63 that I just read to you. And then how do geologists figure out rock layer puzzles? Okay, well, to find that, you're going to have to look in this paragraph right here. Okay, so I'm going to stop this video right here, this video will get you through so this video is going to get you through the last paragraph of page 60, through the unconformities and the types of folding, faulting, tilting, and intrusion. The next video I make will go to absolute dating, and we'll talk about that. That's section 3. So good luck on that. Message me.